Hello guys and welcome to another video. Let's get right into it. So on this section we solving for x. As you can see, we have these number of problems and we have to solve for x. This is what you have to remember about solving for x, that when you solve for x, you want all the variables of x to be on the left, and then everything that is not attached to that variable of x to be on the right hand side. By that I mean you want x to be by itself on the left, and then the constant, this constant, to be on the right. Okay, and that will give you your solution, or rather the type of solution you're looking for. So for this one, and I want you to notice the marks as well, it's just a 1 mark question. For this one, what you're doing is simply taking this -4 to the right hand side, and every time you take something to the other side, its sign changes. As you can see, this -4, or rather let me say this 4 is negative. When you take it to the right hand side, it's going to become positive. From there we'll add our like terms. Let's see how it goes. So remember, we want the x to be by itself, so we're taking this one to this side. So I'll have x is equal to -7, because on the right I already have this -7, and then this -4 comes this side and becomes a +4. From there I have to add these two. Why am I adding them? It's because they are like terms. Okay, so I'll have x is equal to, when I add these two, I'll have -7 plus 4. What is that going to give me? It's going to give me -3, and that's how I get my answer. Right, let's move on to the next one. Okay, before I move on, guys, I want to make you aware that when you solve for these problems, you can actually use the method of inspection. You don't, in terms of this problem and this one, because when you look at the marks, you can see it's just 1 mark for each question. So inspection would work in a sense that you find the value of x that when you add it with -4, it gives you -7. So let's imagine, we have this -4, and we ask ourselves, what number can give us a -7 when we add it with a -4? It should be a -3, right? Even before we found this -3, because when I say -3 minus 4, I get a -7. So that's another way of you getting the answer. You see, this is what we do: -3 minus 4, and you get a -7. Let's come here. Here you can see that our answer is 3. So we have to find ourselves, we have to ask ourselves, what number can we put here that's going to give us a +3? What number of x? It's simple, guys. We know if we divide 15 by 5, we get a 3. But here we have a +3 dividing a negative number. So it means we also have to have a negative number here. So our inspection would be like this. We would have at the top -15 divided by -3, and we would get, okay, my bad, I meant -5, because we want to get a 3, and that's what we have. Okay, we get a 3 on the side. So the value of x here is equal to -5. But let's actually find the actual value using the method of solving. So this is the problem I have. I have -15 over x is equal to 3. If on the right hand side I have a fraction, I have a normal number, a natural number, I want to turn it to a fraction, because on this side I also have a fraction. So let's do that. And when I turn this to a fraction, I simply divide by 1, right? Can I just write this properly? So I have -15 over x is equal to 3 over 1. So I'm turning the 3 into a fraction. And from here, I'm going to simply just cross multiply. I'm saying this one multiplied by this one, get my answer, and then this one multiplied by this one, get my answer. If you've watched the previous video where I'm solving for x, you'll realize that I use the same method when solving for x. So even with this one, we're solving it the same way as we did in the previous video. So when I say negative, okay, let's start with x. When I say x multiplied by 3, I get 3x. Remember, you always want x to be on the left. Is equal to, and then this side I say negative 15 multiplied by 1, and I get negative 15. I want x by itself, right? So if there's something attached to x, it means I have to actually divide by it. Get what I'm saying? I have to divide by everything and anything that is attached to x. And here, what is it that is attached to x? It's 3. So I have to remove the 3 by simply dividing by it on both sides. When I divide by it on both sides, I'll have x is equal to, what is negative 15 divided by 3? It's going to be negative 5. Do you see that? It's going to be negative 5. So the value of x is actually negative 5. Let's test. If I put x here to check if I'm going to get this, you'll see that my answer is actually correct. So where I see x, I'm going to put a negative 5. So I have negative 15, this one, divided by the x I just got, which is negative 5, and my answer is 3. You see the left-hand side is equal to the right-hand side. That's how this actually works. Let's move on to the next problem. Okay, guys, here's our third problem. Here we're following the same thing, guys. We're saying that we want everything that is x, or rather everything that is x, to be on the left, and whatever that does not have the variable of x to be on the right. That simply means, guys, we are adding our like terms. Okay, so we can see we have 2x on the right, and then on the left, and on the right we have 5x. So it means we want this 5x to be on the left and this 7 to be on the right. Let's do that. So already the 2x is on the left. It's okay. This one we take into this side to the left, and when we take it to the side of the left, its sign is going to change. It's a positive 5, so when you take it to the left hand side, it becomes a negative 5x, right? Is equal to, on the right there's already a negative 5. Then we take this positive 7 to the right, and it becomes a negative 7. Do you see? I've taken this one to the right, I've taken this one to the left. There we go. Here they are. All right. From here, what do we do, guys? We add our like terms. When you add your like terms, you are simply focusing on the coefficients, adding them together under the same variable of what, in this case, of x. So I have 2x minus 5x. So it means when I say 2 minus 5, I'm going to get negative 3x, because I'm adding 2x minus 5x, or you could say 2x plus negative 5x. Same thing. On your calculator, you're saying 2x minus 5x, but you can't write the x, guys. You can only just have the numbers on the calculator, okay, or in your head, whatever way you prefer to use. Then this is equal to what is on the right. We say negative 5 plus, or rather negative 5 minus 7. You can do this on the calculator, guys, for those who tend to make mistakes. Negative 5 minus 7. You do it like this, and your answer is going to be negative 12. Press equal to, and you see, you get a negative 12. From here, remember here we had 3x is equal to negative 15, and I said what is next to x should be removed. You remove it by dividing by it on both sides. we have the same situation here. There's negative 3 next to x, so I have to get rid of the negative 3 by dividing by it on both sides. These are going to cancel. Then I remain with x on the left. Then when I say negative 12 divided by negative 3, I get a positive 4. And then I'm done solving for this particular problem. Let's move on to the next one. Alright guys, here is another one. Again, I'm going to repeat what I've already said. We want everything that has x to be on the left, and whatever that doesn't have the variable of x to be on the right. So it means this negative 4 is going to be on the right hand side, and when it goes to the right hand side, the sign is going to change to a positive, right? So when we proceed, we have 3x over 2. We take this negative 4 to the right, and on the right there was already 8. When we take this one this side, it becomes a positive 4. And then from here we add these two numbers because they are exactly the same. They are both constants, or they are both numbers without the variable of x. So I'll have 3x divided by 2 is equal to, what is 8 plus 4? The answer is 12. And then we want to get rid of these now, this fraction. How do we do that? We simply turn this one into a fraction, and then we cross multiply. Okay, this one and this one are multiplying each other, right? Remember, if this is just a natural whole number, simply turn it to a fraction by dividing by 1, and then from there you multiply like this. You say 3x multiplied by 1, you see 3x multiplied by 1, and you get 3x. Then you say equal to, move to this side, 2 multiplied by 12, and that's going to give you 24. There is something attached to x. Do you see that? So we have to divide by this number that's attached to x, which is called the coefficient of x. Divide by it on both sides. You know these cancel, so you have x is equal to, what is 24 divided by 3? The answer should be 8 rather. 24 divided by 3 is going to be 8. Okay, that's what you are going to get. Right, let's move on to the next problem. Okay guys, here's another problem. Here we are saying we have to solve for x, but there's a problem, guys, as you can see. What is the problem? The problem is that there is a bracket, and according to BODMAS, we have to get rid of this bracket first and then continue to solve for our x. And in order for us to remove this bracket, we require the use of the distributive property. And the distributive property works in a sense that we take what is outside the bracket and multiply it with everything that is inside the bracket. So I'll take this 4 multiplied with x, then take the 4 again and multiply it with negative 2. So let's do that first and then proceed as we go to our final solution. So what is outside the bracket is multiplied with what is inside the bracket for us to remove the bracket. So I'm going to say 4 multiplied by x, 4 multiplied by x, then minus 2 multiplied by 4 is equal to 12, right? What is 4 multiplied by x? The answer is 4x. And then what is negative 2 multiplied by 4? It is negative 8 is equal to 12. Then when I'm here now, remember, I want the variable of everything that has the variable of x to be on the left, and everything that does not have the variable of x to be on the right. So it means I'm taking this negative 8 to the right hand side, and you know it's going to now become a positive 8. So I will have 4x is equal to 12. When I take this one to this side, it becomes a positive 8. Then I move down, say 4x is equal to, add these two numbers. What is 12 plus 8? The answer is 20. Then from there, I can see that, guys, when I'm here, I have a number that is attached to x. We call it a coefficient. It means I have to get rid of this number so that x just remains by itself. And for me to get rid of this number, I have to divide by it on both sides. So when I get rid of it this side, I remain with x only. And this side, when I say 20 divided by 4, I should get a 5, right? So my answer is going to be 5 here. And I'm done solving for this particular problem. Okay, let's see if we can do something else. Okay, here's another problem, guys. This one is an exponential equation, and for you to solve this one, this is what you need to know, that when dealing with exponential equations, you always want the base on the left to be equal to the base on the right. And when the bases of both sides are the same, the exponents of those two bases will be equal to each other. So when you look at this problem, we can see there's a problem. What is the problem? The problem is that this side, we do not have the base of 3. We just have a number that is 81. And we have to convert this number, actually. We have to convert this number into an exponential number, right? Meaning that it has to have the same base as this one, which is 3, to the power of a certain number, all right? So that's what we're going to do. We're going to change this 81 into an exponential value so that this number ends up being an exponential value that has the same base as this one. So we'll have 3 to the power of 2 minus x is equal to, already we know that the base on this side is supposed to be the same as this one. So here we will have 3, the same base as this one. Do you see that? And then find the exponent. What is going to be the exponent here? The exponent is going to be 4. You can find this using prime factorization, okay? When you use prime factorization to solve this number, you simply divide him by 3 and so forth. You're taking 81, prime factorization, I use the ladder method, and then you say 81 divided by 3, get 27. Then you divided 27 by 3, you would get a 9, divide the 9 by 3, you would get a 3, and then divide the 3 by 3, you would get a 1. Now you are done. Simply multiplying these numbers together, and you see how many 3's you have here. 1, 2, 3, 4. So your answer is 3 to the power of 4 for this. That's what you basically do. Okay, that's how you get this 3 to the power of 4, because of multiplying these numbers together. And you know, when you multiply these numbers, you are simply adding the exponents. Why? Because you are multiplying bases that are the same. So you are adding the exponents under the same base. What is 1 plus 1 plus 1 plus 1? The answer is 4. So that's how you basically get the 3 to the power of 4. Now, guys, you can see that the left-hand side, or rather the base on the left, is the same as the base on the right. And that fact means that the exponents have to be equal because of these bases being the same. So I will have 2 minus x is equal to 4. And then from there, I want everything that does not have x to be on the right. So this 2 is going to come this side, meaning I'll have negative x is equal to 4 minus 2. Why am I getting a minus 2? Because this one was positive. When I take it to the right hand side, it becomes negative. Then I'll have negative x is equal to 4 minus 2 is what? It is 2. I divide here by negative 1. Okay, let me take it here because I don't have space. So I have negative x is equal to 2, and next to x you can see I have a negative 1. I have to get rid of this negative 1 because I only want to remain with x. So I divide by negative 1 on both sides. These ones cancel, and then x is equal to negative 2. That's how we solve for our x, and then we are done. Okay.